A shader is a set of instructions to the GPU which execute it all at once for each pixel in the screen. The position and the color of all pixels used to construct a final rendered image can be altered using algorithms defined in the shader and can be modified by external variables or textures in Unity Engine. I believe the best way to learn is by experimenting in Unity immediately. So let's go to Unity and create a new only shader to show you the difference between the coded shader and shader graph. We will be using the Universal Render Pipeline, the URP template, in the entire course. Because shader graph is only available in URP and HDRP, we will explain the differences in the next video. So right-click, New, Shader, Only Shader, and that will create your first coded shader with a simple texture attribute or property. If this is the first time you open a coded shader, you will see a complex code that might be for you a mystery box or a black box. But don't worry for now, we will just show you the difference between the coded shader and shader graph. So now we need to add another property, which is the color, main color, its type of color, and we will color it with white by setting the values to 1 on all axes. Then we need to declare a fixed for color property. Then we multiply that with the texture to color our object texture with the color that we desire. Now save the file and close the Visual Studio, go back to Unity, and we need to create a material that will contain our shader. So we add the shader to the material, then we apply the material to our game object. So create a new material, name it symbol color material, then drag the shader on it, then drag the material on the game object. And now as you can see in the inspector, we have the default texture property, which is created by the default shader, and we added to that the color property, which allows us to change the color of the texture by multiplying the color with the main texture. So this has been done with the coded shader. Now let's try to do it in the shader graph. To create a shader graph, right-click on the files in the inspector, choose shader graph, then URP, then choose only shader graph. And by the way, only shader means the game object will not be affected by the lights in the scene. The purpose of the shader graph is to show you visually the results of the shader without the need to be an expert in coding, and that eliminates the errors that happens while you code. And additionally, you can experiment and see what you can get visually. In this simple shader, we will need two properties, the main texture, so create a new property to the texture and another property for coloring. Then we simply need to multiply them together. To apply any texture to the game object, we simply need a sample texture 2D node, then link the property to it. After that, we need to multiply the sample texture 2D, so we use multiply node. And finally, we drag the color property that we created and we multiply it with sample texture 2D. Then link the final results to the color on the master node. Save the shader graph, go back to Unity, then drag the shader graph onto the material, then drag the material onto the game object, and you will get the same results without much efforts. So as you can see now in the inspector, you can do the same, change the texture of the game object in addition to changing its color. In the next video, we will learn what is render pipeline and what is the difference between Unity render pipelines, the built-in render pipeline, the URP, and the HDRP. So what is a render pipeline? A render pipeline performs a series of operations that takes the content from your scene and displays it on the screen, which is a high-level process contains three operations, which are generally the culling, then rendering, then post-processing. Culling means that we only show vertices or the points that's visible for the camera. For example, we only render what the camera sees, or for example, we only render the front side of the game object to save performance or to keep the game smooth. Then rendering, which generally is the core of the shaders and the shader graph, by knowing the color and the position of each vertice. And finally, the post-processing by adding some effects after rendering the game object, something like the bloom or vignette and something like that. Unity have three main render pipelines, which are the built-in render pipeline, the universal render pipeline, URP, the high definition render pipeline, the HDRP. Different render pipelines have different capabilities and performance characteristics, and are suitable for different games, applications, and platforms. It's difficult to switch a project from one render pipeline to another because different render pipelines use different shader outputs and might not have the same features. It is therefore important to understand the different render pipelines that Unity provides so you can make the right decision for your project early in development. The built-in render pipeline is the legacy render pipeline that Unity uses, and it is a general purpose render pipeline that has limited options for customizations, and of course it only accepts coded shaders, not shader graph. In our course, we will focus on the universal render pipeline, the URP, because it's a scriptable render pipeline that quick and easy to customize and lets you create optimized graphics across a wide range of platforms, and of course that's suitable for mid-range PCs in addition to mobile devices. So all our course will be focusing on URP. And finally, the high definition render pipeline, which is a scriptable render pipeline that lets you create cutting edge high fidelity graphics on high-end platforms. And that's suitable for high-end PCs and the high-end platforms such as the newest Xbox and PlayStation. We will be focusing, as I mentioned, on the URP because it provides artist-friendly workflow that lets you quickly and easily create optimized graphics across a range of platforms from mobile to high-end consoles and PCs. So in the next video, you will learn how to create a new Unity project from the scratch using the universal render pipeline. In all our course, we will focus on Unity URP template, the universal render pipeline. So to create a new project, open the Unity hub and select create new project. I'm using currently the Unity 2021.3.5, and of course we can see there are two types of URP templates for 2D video games and for 3D. It's the same process. In this example, we can try the 3D URP. Just name your project. Let's say first 3D URP and click create project. And this is what you will see first time you open a Unity URP project. To make sure that you are using the URP template, you can go to edit, project settings, and in the graphics tab and quality, you should see the URP high fidelity has been chosen by default. Of course, that's based on which platform you're targeting. If you're targeting high-end PCs, you can choose the high fidelity. If you're targeting maybe mid-range PCs, you can choose balanced. If you're aiming to a lot of platforms, including mobiles and low-end PCs, you can choose the performant URP. I'll keep it at high fidelity. As you can see, there are a lot of properties that can be adjusted easily in the inspector, and some of the shaders we will use requires to enable some features like the depth texture or opaque texture. Depth texture allows to detect the depth from the main camera to the game object, and opaque textures allow some transparency. Later we will use those when we create glass simulation or underwater distortion. This requires to enable the depth texture and the opaque texture. We will not go in details for each property, as you will learn them step by step as we proceed with more complex shaders. So now, what if you already have a project that uses the built-in shader and you want to upgrade it to URP? I'll explain that in the next video. Now let's assume another thing. Let's assume that you started your project using the 3D built-in renderer and you want to upgrade to Unity URP. So let's create a Unity built-in renderer project, the 3D core project template, built-in. And I can add some graphics from the packages that I own. Let's see. So for example, you can download the low polyfence pack and open their scene. Okay, it's rendering fine. So now let's assume you have a Unity built-in renderer project and you want to upgrade to Unity URP. The first thing you need to do to go to Package Manager and then go to Unity Registry, go down and find the Universal RP, install that. Now if we go and check the project settings, we'll still see there is no scriptable render pipeline settings. We can solve that by right-clicking on the project and create, then go down to the bottom, rendering. You can choose whether you want URP for 2D or for 3D. So we click, in our case, 3D one, which is the Universal Render Pipeline. We can call URP. Now if we click here in the scriptable render pipeline settings, we can choose our URP. Then we go to the quality, and again, the render pipeline asset, we want the Universal Render Pipeline to be activated. Click continue. But now, as you can see, when you upgrade from the built-in shader to the Universal Render Pipeline, everything will go pink, and that's because we need to upgrade the shaders to work in URP. To do so, we go to Window, then Rendering, then Render Pipeline Converter, and we say we want to upgrade from built-in to URP. Then we check material upgrade, because the old materials contains the old shaders, and simply we click then initialize converters and then convert assets. That will solve most of the old shaders and game objects, but you might see that there are some game objects in your game that still pink. In that case, either you need to create a new shader graph from scratch, or we can create a new material and name it floor, then assign a material to it and maybe coloring it, then drag and drop in the game object that still doesn't have the correct shader. So that's it for this video, and we are now ready to create an awesome shader graphs. See you in the next video. Okay, in this section you will learn how to create 2D shader graphs. But if you prefer to start with the 3D, you can move to the 3D shader graph section. Also, you can learn here a lot of things that is common between 2D and 3D shaders, in addition to learning some techniques which is common between 2D and 3D. So we will start by creating some 2D shader graphs. We will start very simple from the simplest shader that you can imagine, which is the default shader for 2D sprites. So let's create new Unity 2D URP project and let's name it default simple shader graph. How we can create a simple shader graph that renders a simple sprite. Okay, let's bring any 2D sprite. I'll use my library, package manager, and let's type my assets 2D. We can use the 2D platformer assets pack, which is free on Unity Asset Store. Let's download that and simply let's drag any 2D sprite to use it as an example. Let's choose this nice tree. Okay, we have this tree, and as you can see in the shader here, it uses the Unity Universal Render Pipeline to the sprite lit default. But we can't change anything here, nor the color, nor any property. What if we want to create our own version of the sprite lit default shader, and we will use that as an introduction for your first shader graph that you will create? So let's go to assets, right click, then shader graph, URP, sprite lit custom shader graph. With the difference between the lit and the unlit shader graph, the lit will be affected by the lights in the 2D scene. The unlit one will not be affected by any lights in your scene. So let's name it first 2D shader. Double click on the shader graph to open it. We can double click here to maximize size of the screen of the shader graph. And here is what you'll see the first time you open shader graph. On the left, you can see the properties you create for your shader graph. On the right is the inspector where you can adjust the settings. And in the middle, all this screen to create your shader graph. Any shader graph consists of two parts, the fragment and the vertex. The vertex have all properties related to the position, normal, and the tangent of the vertices, while the fragment one, everything related to the color and the alpha of each vertice of the game object. So for the first shader graph, to create the default lit 2D shader graph, we need, of course, a property. Our first property will be the texture 2D. We want to render the sprite, which is a texture 2D. So we create texture 2D property and name it main texture. We can drag it here. To render a 2D texture, we simply need to create a node. You can create a node by right click anywhere, empty, then click create node, or you can click space and start typing. So we need sample texture 2D to render our main texture. Then we link it to the texture. We can here choose from the inspector, the graph inspector, any sprite. In our case, I will keep with this tree. And if you want your shader graph to automatically detect the main texture as the sprite, so for example, we placed the tree. If we write here main text, it will automatically detect the sprite on the game object and use it as a main texture. This is useful if you want to use a shader graph on multiple sprites easily. Then we link the sample texture 2D to the base color. Let's save, go back to Unity. Let's go to our scene. Now how we can apply the shader to our sprite. We need, of course, a material first. So let's create a new material, default lit shader. Then we drag the shader graph into the material. Then we drag the material either here on the sprite or here in the hierarchy on the game object. Now for this tree specifically, everything went fine, but sometimes you will see some extra edges around it because we didn't use the alpha. See here, the alpha is black. So in case you faced some issues with your texture and you want to use the alpha in your sprites, you need to go back to your shader graph and add one more step, which using the alpha from your photo or texture and assign it to the alpha on the fragment. See, now it's transparent. Before it was using the black color, which is not consistent with all sprites. So connect the alpha from the sample texture 2D to the alpha on the fragment, and now you will get the perfect results. So congratulations, you have created your first 2D shader graph. In the next lessons, we will increase the complexity of the shaders gradually, so you'll learn new tricks, new technologies, and new visual effects.